Alright, Year 9, coming into week 7 here, we're going to look at angles of elevation and depression this week. So this is just a further application of trigonometry and where we can kind of see it in the real world. Now last week you made your own clinometers, which were ways of measuring angles of elevation and depression, and I asked you to try and measure something around your house and play around with that. And today what we're going to do is just a bit of further practice with some of that. So let's define, what does elevation and depression mean? Well, if you are standing there and from your eye line you draw a horizontal line and then you look up to something, so from that horizontal looking up to something, that's what we describe an angle of elevation. And if from the horizontal looking up is elevation, then from the horizontal looking down, that's depression. Now, something that's super important that we're looking for when we're talking about angles of elevation and depression is this word from. Whatever that word from, whatever follows straight after it, that is where we are looking. Okay, that's where we're going to start. So the elevation from A. So that means starting at A, going to the horizontal, and then looking up because it was elevation. So from A, starting at A. Over here on the other side, it's depression from B. So that's starting at B, going out to the horizontal, and then looking down. All right. Something interesting I want you guys to notice here about angles of elevation and angles of depression is that they are very, very similar triangles. So almost, they're reflections of each other. If I pick up the triangle that's my angle of depression, I can carry it across and I can form a beautiful right-angled triangle, well, not a right-angled triangle, a rectangle with those two triangles. And we know that rectangles contain four 90-degree angles. And then what we can see here is those two green highlighted sections, they're actually the same angle as each other. So if I'm thinking about it, the elevation from angle A, if I'm looking up at something and then someone's up high looking back down at me, like what we have up here, the angles of elevation and depression from the opposite ends are equal to each other. So that's something pretty cool. All right, let's mathematically prove that. So here I've got my right angled triangle, and what I'm going to do is I'm just going to complete that rectangle. So if I draw my dotted line along here and draw my dotted line down here, you can see now I've completed that rectangle here, and there's my right angle. Now I know a triangle in total is 180 degrees. This corner here, it's got to be a right angle because it's a rectangle. So 60 plus what equals 90? 60 plus 30 degrees. So that corner up there is 30 degrees. Much the same down this bottom corner here, it's a right angle. So 30 plus what equals 90? Well, 30 plus 60 degrees equals 90. And what you can see here is this 30 degrees here, it's the same as that 30 degrees up there, and the 60 up the top is the same as the 60 down the bottom. Now that comes back from parallel lines and alternate angles, but we just need to remember here that those angles, when we're looking up and down from the opposite ways, are going to end up being equal to each other. Let's jump through, let's do an example, and then let's get on with some work. So our question here, the angle of elevation to a boat from, there's our word from. So let's just highlight it, from a submarine. It's super important. Is 30 degrees. If the submarine is 50 meters underwater, what is the direct distance to the boat? Right, so then scrolling a little bit further down here, we can see our diagram. Now, we were told that the submarine was 50 meters underwater, and that the angle of elevation from the submarine, so that means starting at the submarine and looking up, is 30 degrees. And we're asked to find the direct distance. So we're asked to find this. All right, remembering to throw in our SOHCAHTOA, and we're going to follow all those steps. Let's labeling the sides. I recognize that 50 is the opposite side, and x, well, it's the hypotenuse. So what deals with opposite and hypotenuse? That's sine. So I know that sine of theta is equal to the opposite side over the hypotenuse. Substituting my information in, sine of 30 is equal to the opposite side either over the hypotenuse. And remembering that when our unknown is in the denominator, that these two just switched places. So x is equal to 50 over sine of 30 degrees, and x is equal, when we put that onto our calculator, we're going to x equals 100 meters there. So there's a direct distance of 100 meters between the submarine and the boat. All right, guys, your all work for this week. If we go down, there's underneath this, there's 6 questions that I'll actually complete in the worksheet with the solutions following on after that. Also, if you have some time at the end left in this lesson, have a go at completing the 10 quick questions, and again, their answers are also below. What you need to do then is make sure you correct your work from the solutions, also on this worksheet, fix any errors in your working out, take a photo, upload it to Canvas by Friday the 27th. Remembering, if you want some more examples, on the screen now are some links to some more worked examples and the playlist from all the rest of our trig that we've done this term. Alright guys, good luck with it, and I'll catch you next time.